All right, let's dive right into this. I want you to imagine for a second that you are a time traveler. Seriously, picture it. You are sitting at that tiny desk in the exam hall, the clock is ticking, the invigilator is pacing the aisles, but you are totally calm. Why? Because you've already seen your completed, fully graded Cambridge computer science paper. You already know exactly what the examiner checked off with their green pen, and you know exactly where they drew those dreaded red circles. Now, if you could take that knowledge, if you could work backwards from that absolute, undeniable success, how would you change the way you study right now, today? Well, welcome to this explainer. Today, we are absolutely cracking the code on Cambridge exam strategy, and we are specifically focusing on a topic that literally trips up thousands of students every single year. I'm talking about hexadecimal representation. And listen, whether you are sitting for syllabus 0478, 0417, 2210, or 9618, what we are going over today is going to fundamentally change how you construct your answers. We are definitely not just going to sit here and memorize facts today. No way. We are going to reverse engineer the examiner's brain. We're going to look at actual past paper scenarios, we're going to dissect them, and I'm going to show you exactly how to guarantee those top-tier marks. So get ready.
But before we can even begin to talk about exam technique and scoring points, we really have to anchor our foundational knowledge. We have to ask ourselves, what digital problem does hexadecimal actually solve in the real world? Now, if your immediate thought just now was simply, oh, well, it's a base 16 number system, or maybe it uses the numbers 0 to 9 and letters A through F, I gotta be honest with you, you are already in serious danger of losing marks. Cambridge examiners absolutely do not want rote memorization of isolated textbook facts. They want to know that you understand the real-world application of these concepts. Hexadecimal solves a very, very specific human-to-machine problem. Think about it. Computers read binary. They thrive on long, endless, microscopic strings of ones and zeros. But humans, we are terribly flawed when it comes to reading binary. We make massive mistakes when we try to look at 32 or 48 bits of continuous ones and zeros. Hexadecimal is the bridge. It compresses those insanely long binary strings into much shorter, way more manageable, human-readable chunks. It's used by programmers when they're trying to debug massive memory dumps, or by network admins trying to configure MAC addresses without going completely cross-eyed. If you don't understand that why, the human readability factor, you are going to seriously struggle to answer the how when you're sitting in that exam.
So, to get you operating at that A-star level, here is our game plan. 1. The challenge. 2. The strategy reveal. 3. The transformation. 4. An interactive workshop. And 5. The final system. Let's get right into it.
Section 1. The challenge. Why do really smart students end up failing? There's this massive, heartbreaking gap between what students think is enough to get an A and what Cambridge examiners actually demand to see on the paper. Let's break down two classic traps that we see all the time. First, let's talk about a student we'll call Alex. Now, Alex has studied incredibly hard. When faced with a 4-mark question about why hexadecimal is used in a specific hardware device, Alex writes this giant, massive paragraph. I'm talking about explaining the entire history of base 16, drawing out a full binary to hex conversion table, and listing literally every single place hexadecimal could possibly be used in the known universe. Alex completely overloads the answer with raw computer science facts, but provides absolutely zero analysis of the specific device that was actually mentioned in the prompt. The result? 0 marks. All that effort for nothing. Then on the other hand, we have Sam. Sam takes one look at the clock, completely panics, and just rushes. The command word for the question was explain, but Sam just scribbles down, hex uses less space. Let's pause there. Not only is that factually incorrect because it takes the exact same amount of computer memory to store the value whether it's in binary or hex, but Sam has completely missed the command word's requirement to actually detail a process or provide a reason. Two completely different approaches to the exam, but both lead to the exact same outcome. 0 marks.
The source material for these exams highlights several very specific pitfalls that you absolutely must avoid if you want those top grades. First up is vague wording. This is a killer. Writing down something like, it's easier for the computer is a classic mistake. Remember what we just talked about? It's easier for the human, not the computer. The computer couldn't care less, it runs on binary anyway. Second is confusing similar terms. A massive error in computer science exams is confusing memory with storage, or confusing a MAC address with an IP address. If the exam question is specifically asking about MAC addresses and you start rambling on about routing data across the internet, you instantly lose the mark, period. Third, missing process steps. If you are asked to explain how a device uses hex to display an error code, you cannot just skip straight to the end result. You have to walk the examiner through the process. Finally, and I cannot stress this one enough, is ignoring the provided context. If the exam question specifically sets the scene with a robotic arm in a car factory, your answer must actually mention the robotic arm or the car factory. If you just copy and paste a textbook definition from your brain onto the paper, the examiner will penalize you. Context is absolutely everything.
Section 2. The strategy reveal. It's time to decode exactly what the examiners are looking for.
Okay, now that we know exactly how Alex and Sam lost their marks, the big question is, how do we guarantee that we get ours? Behind the scenes, Cambridge exams are built entirely on something called assessment objectives. You'll usually hear teachers call them AO1, AO2, and AO3. Think of them like leveling up in a game. The progression moves from AO1, which is just simple recognition of terminology, like knowing that hex goes up to the letter F. Then you move up to AO2, which is understanding. That's being able to explain why it's used instead of binary. But the top marks, that elite level, the difference between being stuck at a B and securing that A star, that lies in AO3, applied context-driven reasoning. When an examiner asks you a question about hexadecimal representation, they aren't just testing your math or conversion skills. Not at all. They are testing your ability to take a highly technical concept and apply it seamlessly to a real-world situation that you might never have even seen before. It could be an embedded system in a smart fridge, or maybe a security protocol in a multinational bank. You have to prove to the person grading your paper that you can connect the dry theory to that specific real-world application.
So, how do we reliably hit those top assessment objectives every single time we put pen to paper? We use the PEAL framework. If you take nothing else away from this session, let it be this. This is the secret weapon of top-tier students. PEEL. Point, evidence, explanation, link. It's a game changer. First, you make your point. This needs to be a clear, direct, no-nonsense answer to the question asked. Second, evidence. This is where you flex a little bit and bring in specific, accurate technical computer science terminology, words like MAC address, memory dump, or HTML color codes. Third is the explanation. You clearly and methodically describe how the process works in a logical sequence. And fourth, the absolute most critical step that literally everyone forgets under pressure, the link. You must link your entire answer back to the specific scenario provided in the question. If you force yourself to follow this exact structure, it is almost impossible for the examiner to deny you marks. You are quite literally handing them the marking scheme on a silver platter.
Before we jump into the really practical stuff and transform some bad answers into perfect ones, I need you to do something. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now so you don't miss any of these strategies.
All right, Section 3, the transformation. This is where theory becomes practical application. Let's actually put this PEAL framework into practice right now. We are going to turn those red pen marks into green check marks. Imagine sitting in the exam and you see this question: explain why hexadecimal is used to identify devices on the school's secure Wi-Fi network. Now, a totally generic response, the kind that maybe scrapes 1 mark out of 3 if you're lucky, would be something like, hexadecimal is used for MAC addresses, which identify devices, right? I mean, it's technically a true statement, but it is completely generic. It has no depth. Now let's look at a contextualized, top-tier response using our strategy. Hexadecimal is used to represent the 48-bit MAC addresses of the students' tablets. This makes the incredibly long binary strings much shorter and significantly easier for the school's network administrator to read, reducing human error when they are manually typing addresses to whitelist devices on the school network. Boom. Let's break that down. You have your point and evidence right at the start, you have a solid explanation of making binary shorter for human readability, and you have an incredibly strong link back to the school network, the students' tablets, and the network administrator. Full maximum marks. That is how it's done.
To reliably generate phenomenal answers like that contextualized one we just looked at, you need to internalize what I call the 4-step technical methodology. It is a disciplined, step-by-step path you have to walk for every question. Step 1, identify the exact requirement. Literally, look at the command word, circle it. Is it identify, describe, or explain? They all require completely different depths of response. Step 2, classify the relevant data or hardware. Are we talking about HTML color codes, IPv6 addresses, machine error codes? Pin it down. Step 3, explain the sequence so clearly that another learner who has never studied computer science could follow your logic. And step 4, connect it to the context. Does the question want you to explain causes, effects, advantages, or design decisions for that specific scenario? Run every single exam question you ever do through this 4-step filter, and I promise you, your answers will become incredibly sharp, incredibly focused, and impossible to ignore.
Hey, stop scrolling! Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Welcome to Section 4, the interactive workshop. It is time to put you in the hot seat and test your skills. We all know that true learning only really happens when you're under pressure, so Challenge 1 is the data scan. I want you to imagine you are looking at 3 vastly different real-world contexts on your exam paper. You've got smartphones, industrial robotics, and secure banking. You have exactly 60 seconds in an exam setting to extract the core trend here. What is the common thread? Why on earth is hexadecimal used in all 3 of these entirely different, unrelated domains? Think about it. The answer is that hexadecimal always acts as the vital, necessary bridge between complex machine-level binary and human developers. It does not matter if an engineer is staring at an error code on a jammed industrial robotic arm, or if a cybersecurity analyst is meticulously reviewing a massive memory dump after a secure banking breach, or even if a mobile developer is just tweaking an HTML color code to make an app look prettier on a smartphone. The core reason is universal. Hexadecimal reduces the cognitive load on the human. It is always about making those endless ones and zeros easier for humans to trace, log, debug, and copy without making silly errors. If you can train your brain to spot that universal pattern, you can comfortably answer any weird scenario Cambridge decides to throw at you.
Let's move to Challenge 2, Find the Flaw. I want you to listen very closely to this actual examiner commentary from a past paper. The student named the device but failed to explain how the hexadecimal conversion works in this specific embedded system. Man, that is just a heartbreaking way to lose marks. The student clearly studied, they clearly knew their stuff, and they recognized what an embedded system was, but they completely dropped the ball on the explanation phase of our Peel framework. Specificity is everything here. For example, if a question asks about an embedded system inside a smart washing machine, you cannot just get away with writing hex is used for error codes. That's too vague. You must explain the actual process. You have to say that the microprocessor generates a specific error state in binary, which is then converted and displayed as a much simpler 2-digit hexadecimal code, something like E4, on the machine's tiny LED screen. Why? Making it incredibly easy for the repair technician to quickly diagnose the fault without having to read binary. Do you see the difference there? Specificity is the absolute currency of top grades. You have to paint the whole picture.
All right, brace yourself for Challenge 3, the Speed Writing Challenge. I want you to mentally construct a perfect peeled paragraph right now. You've got 30 seconds. The topic is hexadecimal used for error checking, specifically looking at a memory dump after a major system crash. Go. Think about your point. Think about your evidence. You need to mention memory addresses and raw binary states. Think about your explanation. How is that massive string of binary actually grouped? It's grouped into 4-bit nibbles and converted to hex, right? And finally, most importantly, your link. How does this specific conversion help the poor systems programmer find the exact location of the system crash faster? Practicing this structured, methodical answering technique under simulated ticking clock pressure is exactly what transforms a panicked, stressed-out brain into a calm, calculating exam machine.
Section 5, the final system. Let's build your ultimate revision cycle.
To ensure you walk away from this explainer with a permanent, foolproof blueprint for success, you need to adopt this 3-pass revision cycle. Do not skip these steps. Pass 1, secure your definitions. This is the foundation. This is where you make absolutely sure you know the fundamental difference between a MAC address and an IP address, or between memory and storage. If the foundation is weak, the whole house collapses. Pass 2, rehearse your explanations. I mean it. Don't just read your notes passively. Actually write out the Peel paragraphs for worked examples. Practice explaining that binary to hexadecimal conversion process step by step until it's muscle memory. Pass 3, adapt to new scenarios. This is the magic step. This is where A-stars are made. Take your beautifully rehearsed explanation and force it into a totally new, weird context. If you learn the concept by studying a smartphone, rewrite your answer applying it to an agricultural drone. This kind of layered, adaptable learning is exactly what prevents you from getting caught off guard by a weird, unexpected scenario in the real exam.
And as a final, absolute self-checking checklist before you ever submit an exam answer on hexadecimal representation, I want you to use this 4-step memory structure. Just ask yourself these 4 questions in your head. 1. What is it? 2. How does it actually work? 3.
Where is it specifically being used in this prompt? And 4, why is it better or worse than a binary alternative in this exact situation? If your written answer on the page does not clearly address all 4 of those prompts, I guarantee you have left marks on the table. For instance, if you don't explicitly explain why it's better, like mentioning how it reduces human error during manual data entry, the examiner literally cannot award you the evaluation marks. This checklist forces you to build those rich, layered, applied answers instead of just spitting out isolated, useless facts.
2. I want you to focus on that number for a second. Students who actually implement these exact strategies, who stop summarizing and start analyzing, see an average improvement of 2 full grade boundaries. Let that sink in. That is literally the difference between sitting at a C and jumping to an A, or moving from a B to a flawless A star. But here's the reality check. That transformation only happens if you apply the Peel framework to every single past paper you touch from today onwards. It's all about working smarter and visualizing that examiner's marking scheme in your head before your pen even hits the paper.
Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @theacetheexams_IGCSE and click that bell. Don't let another exam pass you by.
Let's summarize the absolute core techniques of our completed paper strategy one last time. If you want those top marks, if you want that A star, you must follow these 3 rules religiously. Rule 1. Command word decoding. Never ever start writing until you know for a fact whether they want a simple identification, a detailed description, or a full evaluation. Rule 2. Peel application. Point, evidence, explanation, link. Anchor your theoretical knowledge to the specific, real-world scenario provided in the text. Rule 3. Time management matrix. Please, do not write a massive 10-minute essay for a tiny 2-mark question like Alex did. Allocate your time strictly based on the available marks and then move on. These 3 rules are your shield and your sword when you walk into that exam hall.
Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.